All right, chapter 1.1, which is applying properties of real numbers. This is mainly a review from Algebra 1, but I thought I'd go through it just in case there were any problems. The first thing in that section deals with real numbers and what real numbers actually are. And real numbers can be put into two different categories. You got your irrational numbers and you have your rational numbers. And the easiest way to remember that is a rational number is anything that can be written as a ratio or a fraction. So I got a couple examples here in red, like negative 1/3, that's a fraction. It's also negative 0.33 repeating. 0.75 is also a rational number because it can be written as 3/4. Another one is something as easy as the number 4. 4 is a rational number because it can be written as 4/1. So anything that can be written as a fraction is a rational number. Irrational is just the opposite. It's any number that cannot be written as a fraction. So like square root of 2, if you were to put that in the calculator and hit math, enter, it would not be able to give you a fraction because it's this decimal here. Same thing with negative square root of 14. There's no way you can put that as a fraction. And also pi, that also cannot be written as a fraction. So those are your two big categories from real numbers. And then below rational numbers, you have integers. Okay, integers are just your counting numbers and then the negatives of those counting numbers. So you've got, everything to the left of -3, -2, -1, then you got 0, and then you got all the positive values, 1, 2, and 3. Those do not include any decimals or anything like that. And then you got your whole numbers, which are the positive integers, which are 0, 1, 2, and 3. Okay. So example 1, it wants you to, this is from your textbook, it says they want you to graph negative 5/4 and the square root of 3 on a numbered line. So the first thing I like to do when I see a problem like this is to convert these two numbers into decimals. That way you can graph them pretty easily. So in your calculator, type in negative 5/4, and it's going to get you negative 1.25. And then type in square root of 3, which is the second button. Then you hit the x squared button, and then you hit enter, and it gets you 1.73 roughly. And just do the best you can with the graph in these. It's not going to be perfect, but I want to be somewhere close to the right area. Like negative 1.25 is not quite halfway between -1 and -2. It's about here. And then 1.73 is a little bit more than halfway, so about right there. And then you're in good shape. So always convert these to decimals. It's a lot easier to kind of tell what's going on. Okay. The next page deals with properties. Properties of real numbers, and these are things you want to get extremely familiar with. Okay. So the first one I want to look at is called the closure property, and this is for addition and multiplication. And what it says is if you were to, and one thing I wanted to note too, A, B, and C are just real numbers. Like they could be anything, 1, 2, 5, -1, it makes no difference. Okay. And it says that if you were to take a real number, A, and add it to another real number, B, you get a real number. Okay, pretty basic idea that if you take a number plus a number, you get a number. Same thing for multiplication. If you take a real number A, multiply it to a real number B, you're going to get a real number for your result. Okay. Commutative property says if you take A plus B, that's the same thing as B plus A. Same thing for multiplication. A times B is the same thing as B times A. That does not work for subtraction, and it does not work for division. Associative property. Made a little mistake when I wrote it out. This is A plus B in parentheses, and then plus C. This is an A outside of parentheses, and then B plus C inside it. And if you notice here, the B is associated with the A in this part, and then the B here is associated with the C. The parentheses shift, but the numbers do not, and that works for addition and multiplication. Identity is where you add or multiply something to a number and it does not change that number. Like adding 0 to A does not change A. Multiplying by 1 to a number A is not going to change that number. Inverse is the opposite operation. So if you want to do the inverse of A, you're going to add the opposite. So A plus negative A gets you 0. Or something like this, 2 plus negative 2 gets you 0. Same thing for multiplication. You multiply the inverse, and multiply the reciprocal, A times 1 over A, which is just 1. Or you can think about it being 2 times 1/2. That gets you 1. Then the last one is distributive property. This one should be pretty basic from your Algebra 1. A times B is AB. A times C is AC. Okay, so example 3, I've added a couple of these that your textbook didn't have. So example 3A says what property is demonstrated here. So 7 plus 4 equals 4 plus 7. If you look at your chart, that is the commutative property. And this is of addition. I'm going to abbreviate a little bit. 3 times 1 over 13, that's multiplying the opposite. So that's the inverse property of multiplication. Question C says you got 6 plus 8 in parentheses, and then you got 8 plus 2. The parentheses shifted, but the numbers did not change. This is the associative property, and this is of addition. And you got 6 times 1 equals 6. That's not changing the identity of 6 by multiplying 1. That's the identity property. And that's of multiplication. Then the last one, E, we're doing 3 times 4 and then 3 times 6. That is the distributive property. Okay? So a way that you might see this being used, you can always look at those and pause these and look at them later on if you need to, is if you had a question like example 4. This is the last example of the section. It says to use properties to show that A plus, then parentheses 2 minus A equals 2. And they have the steps shown out here. And all we want to do is just tell what property they use to get from one step to the next. So what they did here, they started off with A plus and then parentheses 2 minus A. First thing they did was, if you look at it, this little part right here. And that's not really any of the properties that are inside. So we'll kind of move on to the next one there. But all they did was said that negative A turns into plus a negative A. The same thing. If you subtract, it's the same thing as adding the negative. So going from this step to that step, you notice they flip-flopped the negative A and the 2. So that was the commutative property. Okay. And then if you notice, they have these brackets. They were around the negative A plus 2. Now they're around the A plus negative A. That is the associative property. And then what happened was you've got A plus negative A that turned into a 0. Okay, A plus negative A, that's the inverse property. And then the last one, 0 plus 2 got me 2. You add a 0, that is the identity property. Would you ever use this many steps to show that? No, probably not, but that's a good way to look at the properties being used.